My name is Monica Grady. I'm Professor of Planetary and Space Sciences at the Open University. The OU is really well placed to offer a Masters in Space Sciences. The OU specialises in supported distance learning, so you're not doing it by yourself. And the staff who are involved in this Masters, we've all been involved in space missions. We've been involved in the design, in the build of instruments, in the interpretation of the data that comes from it. And so we know what it's like to be part of those teams. And we really want to convey that interest and that excitement to the people who are going to follow in our footsteps, who are actually going to be part of the next set of space missions.
Hello, I'm Mark Jones. I'm a senior lecturer at the Open University and I'm the academic lead for the new Masters in Space Science and Technology, and I'm also the module team chair for our new Masters level module on space science. I'm an astronomer and all my research has been based on observations made from space-based platforms. So I've worked on X-ray, infrared, observatories over 20 years or so. The Masters in Space Science and Technology is designed for people who want to either seek employment in the space sector or to go on to do further academic research in the space sector. It's designed for people from a wide range of backgrounds, mainly from physical science backgrounds, but also from geology or chemistry or engineering or mathematics. And it seeks to build up not only the knowledge that you need to work in the space sector, but also to develop the skills that are sought by employers in the space sector. The qualification is split into three parts, three stages. So the first stage is an introduction to space science, which gives students the background about the principles of making physical measurements in the space environment and using case studies to illustrate those points very clearly. The second stage is to do with the development of professional skills that are important in the space sector, and those split into technical skills such as programming or other engineering related skills, and the other professional development that we have at the second stage is really to do with project management or technology management. The third stage is to conduct a project, an academic project in space science or space technology under the supervision of a tutor in an area that's of interest to the student. The unique feature about the Masters programme is that the introduction to space science is based on a case study approach, using 4 missions that we have experience of, and 3 of those missions with direct academic experience of academic members of staff in at the Open University. So they bring their academic expertise to actually illustrate how space missions really work.
My role in the Masters course is the responsibility for the chunk of the course about the Rosetta mission to a comet. The OU's involvement in the Rosetta mission was to build an instrument called Ptolemy, which was on the Philae lander. It took about 10 years to design and build the instrument, and then it took 10 years for the Rosetta spacecraft to get to the comet before Philae was launched. The idea of the instrument was to sniff the gases which were coming from the nucleus of the comet. Of course, the Rosetta mission is not the only mission that the OU's been involved in. In the past, we were involved in the Beagle 2 mission to Mars. We were the leading partner for that. And also we were involved in the Huygens part of the Cassini-Huygens mission to Saturn. Currently, as well as the Rosetta mission, we're involved in Gaia, which is mapping all the stars. And in the future, we're doing something for missions to the moon. We're also involved in the Euclid Space Telescope. We're involved in the ExoMars mission to Mars, the 2 parts of the mission, the Trace Gas Orbiter, and also the lander. So there's loads of stuff still to come.
My name's Andrew Norton. I'm Professor of Astrophysics Education here at the OU, and on the Space Science Masters I'm working on one of the particular case studies on the Gaia satellite. So my particular area of research is in astronomy, and in particular what you might call time time domain analysis. So I'm looking at how stars and galaxies and so on, how their light output varies with time. This is an area of big data that's increasingly becoming important in astronomy. So something like the Gaia satellite, which we're including in the Space Science Masters, that will continually scan the sky for years at a time, measuring the brightness, measuring the positions, measuring the spectra of millions and millions of stars. From that, we can extract all sorts of information, and that's the sort of thing I'm interested in. How stars vary with time, whether they're multiple stars orbiting around each other, whether they're stars that are pulsating in and out, whether they're stars that undergo transient events, flaring up or exploding. And the sort of things we're going to do in the Space Science Masters really completely fit in with the sort of research I'm doing in time domain astronomy.
The Space Science module that introduces the Masters programme will make a lot of use of remote experimentation. So we have an open STEM laboratory here with experimental kit that's relevant to space science, and students will be operating that kit over the internet and doing real physical measurements as part of their studies.
Students will be controlling experiments here at the OU over the internet, whether that's laboratory equipment such as electron microscopes or particle detectors, whether it's robotic telescopes either here or in Tenerife. We even have a robotic Mars rover in a Mars shed over there, where we have a Martian landscape in our shed, and students will control and drive this Mars rover on the simulated landscape to do experiments as if they were controlling the real rover on Mars. We're also going to focus the Space Science Masters on certain skills that will particularly involve teamwork. Just as in a real space mission, our students will have to work together, collaborate in a team to achieve the outcomes. We'll also include scientific computer programming in the Space Science Masters, because for all these space science projects, when the data comes back, you have to write computer programs to understand and analyse those data. So we will teach Python programming in the Space Science Masters so that our students can analyse space weather data, so that they can analyse data on transient astronomical objects coming down from the Gaia satellite. All of these sort of data projects are vital for space science, and we're going to be training the students to do exactly that.
We expect students to qualify with the Masters in Space Science and Technology will be well equipped to obtain employment in the space sector. There is a growth in the space sector at the moment, particularly in terms of what's called downstream applications. That's using space-based data, and our master's qualification has an emphasis on the use of data obtained in the space environment. Alternatively, students might go on to follow a more research academic career path, and we think that this master's will set up people very well for PhD level research in space science.